Hello students, this video is in continuation of the video which I have already made on integers of class 7th. The topics which we are going to cover today are properties of integers, in which we are going to cover the following properties: closure property, commutative property, associative property and distributive property. We are even going to learn the meaning of additive identity and multiplicative identity, meaning of additive inverse and multiplicative inverse. Now the first property which we are going to cover is closure property under addition. That is, the sum of any two integers is also an integer. That is, if we are having two integers a and b, their sum a plus b is also an integer. For example, 2 plus minus 3. Here 2 and minus 3 are integers, so their sum, that is minus 1, is also an integer. Now under subtraction, the difference of any two integers is also an integer. For any two integers a and b, a minus b is also an integer. For example, 6 minus minus 2. Now we are having two integers, 6 and minus 2, and when we subtract them, the answer is 8, which is again an integer. Now under multiplication, that is, when we multiply two integers, we get an integer. For any two integers a and b, a into b is also an integer. For example, 4 into minus 3. Both are integers and their answer is equals to minus 12, which is again an integer. Now under division. Now closure property does not hold under division. Why? Let's take an example. When we divide 8 by minus 10, we get our answer as minus 0.8 after simplification, which is not an integer. Now the second property is commutative property under addition. That is, for any two integers a and b, a plus b is equals to b plus a, which means we can add two integers in any order. For example, 3 plus minus 5, our answer will be minus 2. But when we change the order, minus 5 plus 3, again we get the answer as minus 2. Now under subtraction. Now commutative property does not hold under subtraction. Why? Let's take an example. 3 minus 7 is equals to minus 4. But when we subtract 7 minus 3, we get 4 as the answer. That is, 3 minus 7 is not equals to 7 minus 3. Now under multiplication, for any two integers a and b, a into b is equals to b into a. That is, we can multiply our integers in any order. 7 into minus 8 will be equals to minus 8 into 7, which is equals to minus 56. Now under division, integers do not satisfy commutative property under division. Let's take an example. When we divide 16 by minus 4, we get the answer as minus 4. But when we divide minus 4 by 16, we get the answer minus 1 by 4. That is, we cannot divide integers in any order. Now the next property is associative property under addition. When we have three integers a, b and c, we can add any two integers first. That is, a plus b plus c will be equals to a plus b plus c. For example, when we add 2 plus 3 plus 5, here we are adding 2 plus 3 first. So 2 plus 3 is 5 and 5 plus 5 is 10. Also, 2 plus 3 plus 5, when I am adding 3 and 5 first, again we get the answer as 10. That is, while adding integers, we can add any two integers first. It does not make any difference. Now under subtraction, integers do not satisfy associative property under subtraction. Let's take an example. When we subtract 3 minus 7 minus 2, here we are first subtracting 3 minus 7. So minus 4 minus 2 is equals to minus 6. But when I subtract 7 minus 2, that is 3 minus 5 will be equals to minus 2. That is, here in this case, when we are subtracting two integers, the answer is not same. That is, we cannot subtract any two integers first. Here the order matters. Now under multiplication, for any three integers a, b and c, a into b into c will be equals to a into b into c. That is, for multiplication of integers, again, we can multiply any two integers first. For example, 2 into minus 5 into 3 will give us the answer as minus 30. Here we are first multiplying 2 and minus 5. But when I multiply minus 5 and 3 first, then also I get the answer as minus 30. That is, while multiplying integers, again the order does not matter. Now under division, integers do not satisfy associative property under division. Let's see how. When we divide 24 by 4, minus 4 first, we get the answer as minus 3. But when I'm dividing minus 4 by 2 first, in that case we are getting the answer as minus 12. And here the answers are not same. This means while dividing integers, we cannot divide any two integers first. Now our last property is distributive property. Now distributive property of multiplication over addition. That is, for any integers a, b and c, a into b plus c is equals to a into b plus a into c. Here if you notice, in the bracket it's written b plus c. That is why this property is distributive property of multiplication over addition. So now what we are doing here, we are distributing a to b as well as to c. That is why it becomes a into b plus a into c. So now I have taken one example, 10 into 6 plus minus 2. So we are going to distribute 10 to 6 as well as to minus 2. And after simplifying, we get the answer as 40. Now distributive property of multiplication over subtraction. Now in this, if you see, in the bracket we are having a minus sign. That is why it is called distributive property of multiplication over subtraction. So a into b minus c will be equals to a into b minus a into c. For example, minus 5 into 4 minus minus 6. So here we are going to distribute minus 5 to 4 as well as to minus 6. And after simplification, we get our answer as minus 50. Now our next topic is additive identity. Additive identity we have already covered in the previous video. That is, when we add 0 to any number, we get the same number. So 0 is called the additive identity. Why it is called the additive identity? Because we are adding 0 and we are getting the same number. That is, a plus 0 is equal to 0 plus a, which is equals to a. So 0 is called the additive identity. Now, additive inverse. The number that when added to a given number gives 0. For any integer a plus minus a is equals to 0. Now additive inverse is that number which you will add to the given number and you will get your answer as 0. For example, if I add minus 9 to 9, the answer will be 0. And if we add 7 to minus 7, our answer will be 0. So both 7 and minus 7 are additive inverse of each other. Now multiplicative identity. Like we were having additive identity, now we also have multiplicative identity. So now in multiplicative identity, what does it mean? That when we multiply 1 by any number, we get the same number. That is why 1 is called the multiplicative identity of all the numbers. For any integer a into 1 is equals to 1 into a is equals to a. For example, minus 15 into 1 is equals to minus 15. Now multiplicative inverse. The number that when multiplied by a given number gives the answer as 1. For any integer a into 1 by a is equals to 1. Now what is multiplicative inverse? You have to think of a number which you will multiply to the given number so that you get 1. Now for example, here we are given minus 7. So what will I multiply by minus 7 so that I get 1? So my answer will be 1 upon minus 7. So if you have observed one thing, for multiplicative inverse, we take the reciprocal of the number. That is, reciprocal of minus 7 will be equals to 1 upon minus 7. But for additive inverse, we change the sign of the number. If we move again to that example, the additive inverse of 9. What is the sign of 9? It's positive. So change its sign. It will become minus 9. So minus 9 is the additive inverse of 9. But if I ask you what is the additive inverse of 11? Now again change the sign. It will become minus 11. So I hope you all are clear with all the properties and the meaning of additive and multiplicative identity and additive and multiplicative inverse. Goodbye students.